All right, so we were given the task of deploying the Game Night application, and our team is called Better DevOps. I'm Preston Moody. I'm a 7-year Air Force veteran. We have Matt on our team. He's a Navy vet. We have Chase Sims. He's an Air Force vet. And Akeem Sani, who's also a Navy veteran. Here's our application. Essentially, our application is planning an event planner for game night for everyone. You can log in, sign up, and search events, create events, and get all of your friends together. Just one central platform to plan a game night.
So here's the architecture diagram. We have top right, users accessing the application, and bottom right, devs accessing CI/CD and version control with all the other infrastructure behind it. Technologies used for this deployment include Terraform, AWS, Elastic Kubernetes Service, RDS, Relational Database, and Docker.
Yeah, so for containerization, basically the first step, right? We decided to do a multi-stage Docker build to minimize the overall image size, just make things more agile. The first stage uses Node to actually build the static assets of the web application. And what we end up with as an end result is we have the web app and the Django API. The Django API is built in the second stage. And we built a custom entry point to make sure that all the Django migrations are taken care of before actually executing the server through which we can access the web app.
Once we had our Docker file built, we wanted to test locally through an automated approach. So we wrote a Docker compose file. Once we had this file built, we first tested the application with the database container running locally through a Docker container. Then we utilized a local host to ensure the application was functioning properly. Everything was connecting. As you can see in our picture here, that's how we are accessing it, local host. Once this was completed, we tested the application connected to our RDS Postgres database, ensuring our connection to that database was good in all the configurations. Our outcomes from this was we discovered our database configuration was just not correct, which led to troubleshooting and then finalizing our database configurations, and we ensured Docker file was sufficient.
The next step was to set up an RDS Postgres database. We provisioned this using Terraform files, and with this, we set up a VPC module in our Terraform file. The module consists of a private and a public subnet. In the private subnet, that was where we implemented the RDS Postgres in our private subnet. The identifier for the RDS Postgres is a night game DBS, and the instance name is the T3 micro for the class, and we have a storage class of 20 GB. Next, please. And after that was set up, we went ahead to create our EKS cluster, also using a Terraform file. And we have a EKS module that was used in the Terraform file. And we also used the VPC module that was set up earlier using the public subnet for our nodes. The cluster name is Game EKS with a version of 1.2. And we built this in the US East 1 region and with an instance of T3 small. Next, please.
So once we had our EKS set up, we wanted to do a Kubernetes deployment. But first, we wanted to test locally via Minikube. how we tackled this was we built deployment files that had TCP socket probe, service file, config, map, secrets, resource quota, namespace, PV, and PVC. We first tested this locally. Once successful, we configured an EC2 instance and then deployed to our EKS cluster. We did this to take out all of our possible connection issues through utilizing our local machines to connect to our EKS cluster. We all kind of had issues there, so we figured it would be easier to use an EC2 instance and just SSH in. Once we had our EKS cluster running the application, we configured a storage class on a EBS volume, created a PVC claim part of the volume, then mounted the volume onto the deployment pod. As you can see here in our diagram, this is how we did it. We have our user or our developer SSH into an EC2 instance, connecting to our EKS and the cluster, and we configured our storage class.
Now we have just about all of our infrastructure set up. We want to make some automation to update it so we don't have to do it every time. So we used GitHub Actions workflow, and there's 2 jobs contained in that. We have a build and push to update the Docker image on the Docker Hub repository, and we have the Kubernetes deployment job, which automates logging into our AWS account and continuously deploys to the live running application. And on the next slide, there's a screenshot of that showing that it's successfully completing when we push to the repo.
So as far as backups are concerned, we wanted to take daily and weekly snapshots of our RDS database. And so we used AWS Backup for that. We created a vault for the team called Game Night Vault. And you can see that we made a backup plan down on the bottom of the slide there, containing 2 roles, one for daily, one for weekly. Over on the right-hand side, that's the summary of the daily backups. The weekly looks very much the same. It just has different time frames in it. By using this, we could actually automate taking the snapshots and deleting the snapshots, so we're not just holding on to a lot of unnecessary data. And anytime that a snapshot comes in or leaves the vault, we get an AWS SNS email notification for everybody on the team.
Next, we set up CloudWatch to get some information on what's going on with the cluster. We had 2 dashboards. First dashboard here shows us incoming bytes and incoming log events, so we can get data and information on events that are happening in the cluster, as well as count of the node groups and clusters running. And then the second dashboard.
The second dashboard we use for node metrics. This is to include CPU utilization, EBS read ops, EBS read bytes, network in, network out, EBS write bytes, EBS write ops, network packets in, network packets out, and then finally we had a status check for our failed instances to launch. Right after this, we configure our DNS through Route 53 by utilizing a hosted zone and adding our record to it. Essentially, this is how, in this diagram, this is how a user would connect. So they type in gamenightPresentation.org. That then utilizes Route 53, hits our Elastic Load Balancer, and utilizes our auto scaling group, which has our working nodes in it. And then Chase is going to demonstrate our lab application.
Yeah, so this is the live application right now. You can go ahead and sign up here if you guys wanted to. I already have an account, so whoops, that's not where I meant to be. So let's go to log in here. Let's log in. All right, so we are actually getting full functionality with the RDS database.